Hi everyone, and thank you for joining us today. My name is Miloš, and I'm a senior solution architect here at AWS. In today's session, we are going to talk about how Amazon Connect and Amazon Lex can help you to optimize, automate, and scale your customer experience globally. So we're going to start with a brief introduction of Amazon Connect and then explain why conversational interfaces play an important role in modern contact centers. And then we're going to go through Amazon Lex, especially new features and capabilities of Amazon Lex V2. We also have a demo part to see it all in action. At the end, we are opening for any questions you might have. Amazon Connect is a simple-to-use, cloud-based contact center service we brought to market to enable businesses to deliver exceptional omnichannel customer experiences that are natural, dynamic, and personalized. Amazon Connect includes all the standard functionality, such as skills-based routing across different channels, secure and compliant voice call recordings, and chat transcripts. All the common reports and analytics you would expect are available and easy to use, including service level, handle time, and agent performance. With Amazon Connect web-based softphone, agents can be located virtually anywhere using a standard broadband connection and a standard agent kit, such as laptop and a USB headset. And your data is your data. For example, call recordings and chat transcripts are stored in your Amazon S3 bucket, where you can control access and lifecycle policies according to your business needs. You can also leverage a number of integrations already available, such as connectors for workforce management and CRM platforms. Amazon Connect provides real-time dashboards and historical reporting with an easy data lake and data warehouse integrations, allowing businesses to generate cross-platform reports. For instance, combining the data from contact center channels with the data from their CRM and other enterprise platforms. Now, the concept of the contact center has evolved, as have the expectations of customers. The contact center of the future isn't a collection of different solutions for taking calls or chat contacts, and it isn't just an application that consolidates those technologies. It's a platform to make it easy to integrate with your enterprise applications, and it makes it easy to leverage customer data in real time to personalize and contextualize all customer experiences. As self-service offerings mature, allowing customers to solve the majority of their problems on their own or through a virtual assistant, contact centers have become escalation points for customer. In their search for a solution, customers are looking for low effort and minimal friction. Now, organizations are already delivering experiences that are personalized in many areas. For example, mobile applications and websites understand my preferences and dynamically present options and products related to my needs. So my experience as a customer should not be different when reaching out over the phone or through a chat. For example, I could say, I'd like to check the balance on my account, and the system would listen, authenticate me based on my voice, and instantly provide the requested information. And finally, contact center should not just leverage this data to personalize experiences. It should also create the data and insights that are fed back through to enterprise to empower contextualization and personalization across all areas of the business. And this is where conversational interfaces come into play. They're natural, allowing customers to speak in their own words and dynamically tailoring the conversation rather than requesting customers to follow strict instructions. They're also available on demand 24/7, accessible from a variety of devices, and becoming more and more efficient at meeting customer needs. Amazon Lex is a service for building conversational interfaces into any application using voice and text, enabling businesses to add sophisticated natural language chatbots across different channels. It combines automatic speech recognition with natural language understanding. And it natively integrates with the AWS services such as Amazon Connect, Amazon Kendra, AWS Lambda, but also messaging platforms such as Slack, Twilio, Facebook Messenger. It provides accurate automatic speech recognition that quickly transcribes speech to text in multiple languages, which we're going to see later in the demo. And it also supports 8 kilohertz telephony audio, which is very important in contact center environment. Self-service includes automated solutions like chatbots or voice bots, which replace traditional interactive voice response or IVR systems. They enable customers to find answers and resolve issues 24/7 on their own, using interfaces they're most comfortable with and that are available when and where customers want to interact. They can also be used in conjunction with live agents to enable more efficient routing and data capture to help the customer get a resolution more accurately and quickly. Automated self-service solutions are a key component to contact center strategies to enable a better customer experience while also reducing the overall cost. Now, there are 5 key steps in preparing and building your Amazon Lex bot. So first we have script. This is when we write sample dialogues that illustrate the ideal conversational flow. Then we have a design phase where we map out experience and translate scripts into bot components by identifying sample phrases and refine for clarity and brevity. Then we move on to build, where we create a bot and configure intents to define sample utterances and slot values. We usually start with commonly used phrases that we expect customers would say. We move on to test, where we try out the bot in Amazon Lex console to make sure that it's working as expected. And finally, we have a deploy phase. So we publish our bot to customers, then we analyze the feedback and continue to iterate to start the flywheel for continuous bot improvements. Let's first identify different personas or stakeholders in such a project. So first of all, we have an end user, and this is a person interacting with a bot, either through a phone call or using their voice or through a chat using text-based input. Speech accuracy is the most important for end users, so the bot can understand their request when using their own language and phrases. Then we have an author. Author creates the end user experience by designing the conversation flows. These are not Amazon Connect contact flows, and we will see that later. For an author, it's very important to be able to collaborate with other stakeholders and quickly iterate through the design. Then we have a developer, and this is a person with a technical skill set. And they implement the underlying business logic and integrations with other enterprise platforms. The main goal here is to write as less code as possible and to simplify the integrations with other platforms. Then we have an operator. Operator is responsible for governance, making sure there is an easy way to manage different versions of a bot, and focuses on things such as CI/CD to lower the cost of operations. Finally, we have an owner or a business owner, and this is a person who is responsible for the entire project. And they work closely with author, but also developer and operator. Business owners are interested in analytics and return of the investment they have made. They're analyzing the overall bot performance and iteratively trying to improve customer experience based on the provided insights. On the next slides, we are going to see how Amazon Lex V2 addresses these needs and goals. But let's first do a quick recap on Amazon Lex components. So at the top level, we have a bot. A bot performs automated tasks such as booking a hotel, booking a car, and so on. As Amazon Lex bot is powered by automatic speech recognition and natural language understanding capabilities, it can understand user input provided with text or speech and converse natural language. Then within a bot, we have intents. An intent represents an action that the user wants to perform. We create a bot to support one or more related intents. For example, we might create an intent that allows customers to book hotels and an intent that allows customers to book cars. For each intent, we need to provide the intent name, which is just a descriptive name for the intent. For example, book hotel or book car. And then we need some sample utterances. So how a user might express the intent. For example, a user might say, book a hotel, or I would like to make a hotel reservation. An intent can require multiple parameters, or as we call it, slots. We add slots as part of the intent configuration. At runtime, Amazon Lex prompts the user for specific slot values. Slots can be required and not required. The user must provide values for all the required slots before Amazon Lex can fulfill the intent. For example, the booking hotel intent requires slots such as location, check-in date, number of nights, and a room type. But user could also say, I'd like to book 3 nights in London, and Amazon Lex translate this utterance to an intent and capture slot values for location and the number of nights, and then follow-ups just for the remaining slots. For each slot, we provide a slot type and one or more prompts that Amazon Lex sends to the customer. For instance, for check-in date, customer could say tomorrow or next Friday, and Amazon Lex would still understand the slot value. Now, each slot has a type. We can create our own slot types, or we can use built-in slot types. For example, we might create a slot type, room type, with values as queen, king, and deluxe. And finally, how do we want to fulfill the intent after the user provides the necessary information? Most often, we would create a Lambda function to fulfill the intent. In this case, Lambda function would store the booking details into a database, for example. In addition to custom intents, Amazon Lex provides built-in intents to quickly set up our bot. And you can check AWS documentation for full list of built-in intents. Amazon Lex V2 bot can converse in one or more languages. So with our built once, enable everywhere approach, businesses bring the same intelligence automation to voice and digital channels, and Amazon Lex V2 enables us to reuse the same Amazon Connect contact flows and the same Amazon Lex bots to support a diverse customer base in a single conversation interface. We can add multiple languages to a single Amazon Lex V2 bot, and we modify and build each language independently. Now let's see what Amazon Lex V2 brings from builder productivity perspective. So intents and slot types are scoped at the language level. We can quickly move between different languages to compare and refine the conversation. We can also use one dashboard in the console to review utterances for all languages for faster analysis and iterations. A bot operator can manage permissions and logging operations for all languages within one bot configuration. In our Amazon Connect contact flows, we must provide a language as a runtime parameter to converse with Amazon Lex V2 bot. Now we have versioning. A version is a snapshot of our work that we can publish for use in different parts of our workflow. For example, development, beta deployment, and production. Once we create a version, we can use a bot as it existed when the version was made. After we create a version, it stays the same while we continue to work on our self-service application. We version at the bot level so that resources such as intents and slot types are not versioned individually. By default, every bot is created with a draft version, and this version is mutable and used for testing changes. We choose the languages to include in a version, and all the resources within a bot, such as languages, intents, and slot types, are archived as part of creating a bot version. An alias is a pointer to a specific version of a bot. With an alias, we can update the version that our Amazon Connect contact flows are using. For example, we can point an alias to version 1 of our bot, and when we are ready to update the bot, we publish version 2 and change the alias to point to the new version. Because our Amazon Connect contact flows use the alias instead of specific version, all Amazon Connect contact flows get the new functionality without needing to be updated. Amazon Lex V2 also enables us to save partial changes during development, and this flexibility enables us to save our work and return to it later. And with Amazon Lex V2, we can rename a resource after it's created. We can use a resource name to associate user-friendly metadata with each resource. All resources have a resource name, and we can rename our bot, intent, slot type, slot, and alias. Conversation flows are very useful for both authors. Both author can view the conversation flow in a form of a continuous visual flow, as opposed to having to go through different intents and slots. We are going to see this later during the demo. Collaborative editing enables multiple people editing at the same time, and Lex V2 allows to quickly test our bot with exact utterances before it's fully built. In Amazon Lex V2, we define one Lambda function per language, instead of a function for each intent. The Lambda function is configured in the alias for the language, and it's used for both the dialog and the fulfillment code hook. You can still choose to enable or disable the dialog and fulfillment code hooks independently for each intent. And now in Amazon Lex V2, we move the voice and intent classification confidence score threshold from the bot to the language scope. The sentiment analysis flags moves from bot scope to alias scope, so different aliases can have different settings for sentiment analysis. Session timeout and privacy settings are at the bot scope, while conversation logs are at the alias scope. Again, different aliases can have different settings for conversation logs. You can also find all these details in the official AWS documentation. And Amazon Lex V2 bot adds a default fallback intent when we create a language. We can use it to configure error handling for our bot instead of specific error handling prompts. Previously, in version 1, we had to add fallback intent manually. Natural conversations include pauses and interruptions, and this is where new Amazon Lex V2 streaming capabilities are very useful. When bidirectional audio stream is established between an Amazon Lex V2 bot and Amazon Connect, we can configure the bot to listen for user input while it's playing back a prompt. This enables the user to interrupt the prompt before the bot has finished playing it back. And we can use this configuration for situations where the user might already know the answer to a question. For example, when they're prompted to provide a CVV code for their credit card. By default, the user can interrupt any prompt that the bot is streaming, but we can change this behavior on a slot level. With Amazon Lex V2 bidirectional streaming, we can configure the bot to wait for the user to provide additional information. There are situations when a user might not be ready to respond to a prompt. For example, a user might not be ready to provide their credit card information because their wallet is in another room. By using the wait and continue behavior of Amazon Lex V2, users can say phrases such as, "Hold on a second," to make the bot wait for them to find the information and provide it. When we enable this behavior, the bot sends periodic reminders to the user to provide the information. Wait and continue behavior is set per individual slot, and the configuration is very flexible. So we have response when user wants the bot to wait, and this is how the bot responds when the user asks it to wait for the additional information. Then we have response if the user needs the bot to continue waiting. This basically bot reminds the user that it's still waiting for the information, and we can change how frequently the bot reminds the user. And then we have responses when the user wants to continue, and this is when the bot responds when the user has the requested information. For every bot response, we can give multiple variations of the responses and also choose whether these responses can be interrupted by the user. Now let's see the migration. So Amazon Lex V2 provides an automated migration process. It copies your custom intent and slot types to the Amazon Lex V2 bot. In Amazon Lex V1, we had to create a separate bot for each language, but we can migrate multiple Lex V1 bots, each using a different language, to one Amazon Lex V2 bot. Migration also maps built-in slots and built-in intents. But the migration process does not migrate aliases, Amazon Kendra indexes, AWS Lambda functions, conversational log settings, messaging channels such as Slack, and tags. And please check the official AWS documentation for more details on the migration. Now, let's switch to AWS Console to see all of these in action. The goal in this demo was to support multiple languages in a single Amazon Lex V2 bot and to support multiple languages in a single set of Amazon Connect contact flows. Now I have AWS Management Console on my screen, and I have already opened Amazon Lex. So when I navigate to Amazon Lex, I see this welcome screen where I click Get Started. So this brings me into the new Amazon Lex V2 console. And as you can see, I have one Lex bot created already. So I'm going to open that one. And on this welcome screen, again, I can see my bot's name, so V2 test book trip, the description, and the ID of this bot. I can see that my bot has 3 languages and it has 2 aliases. And then I see some analytics shortcuts. So let's look at the left-hand side. So I have my bot, and then I have different bot versions. So basically, if I click on bot versions, I can see that I have draft version, which is the default version, and it's mutable, and this is what I use to edit my bots. And then basically I have different versions moving on, so version 1, 2, 3, and 4. Okay, let's open the draft version. So again, what I can see here is that the version is draft, and then I have the associated alias, which is testbot alias. This is a default alias that's always assigned. And within my draft version, I have 3 languages. So I have English, I have German, and I have Spanish. Now on the left-hand side, I can see the intents and slot types for each language. So English intents and slot types, German intents and slot types, and then Spanish intent and slot types. So in the English language, I click on the intents, and we can see that I have book car, book hotel, and agent support. These are 3 intents that I have created. And then I also have the fallback intent, which was created by Lex V2 when the language was created. Okay, I'm going to select the book hotel intent. And at the top of the screen, I have the conversation flow. This is what we mentioned during the presentation, and this is basically a quick visual overview of our intent. So we can see that the customer could start this intent by saying like book a hotel, and then the bot would ask what city will you be staying in. The customer would provide a city, and then bot would ask what day do you want to check in, and then the customer would provide date, and so forth. So basically, a bot author could quickly see the conversational flow without going into any details in here. Let's close the conversation flow. So we have the intent details, so the intent name and the description, and then basically we go to the sample utterances. So our intent is triggered by customers saying book a hotel, I want to make a hotel reservation, but also book a number of nights in a particular location. So we can add more intents here to enrich the customer experience and to basically allow customers to say and to trigger the hotel booking intent in different ways. Next, we have slots. So basically, for the hotel intent, we have 4 slots. So we have a location, check-in date, number of nights, and then a room type. As you can see here, the slot type for the location is the built-in slot. So this is Amazon City. For the date is Amazon date. For the number is Amazon number. So these are built-in slots which are provided by Lex, so that you don't need to create your own, like the most commonly used. And then for the room type, this is a custom slot type that we created for the for different room types that customer could select. And this is basically an enumeration of Queen, King, and Deluxe. So let's say we expand one of these slots, and we say that this slot is required for this intent, the name of the slot, and then the slot type. The question, so what city will you be staying in? So basically, this is the prompt that Lex would play to the end user. So if I click on the advanced options, what I can see is that slot type is Amazon City. It is required. I can enable slot obfuscation, and then I can choose different slot prompts. So at the moment, I only have one, what city will you be staying in, but I can add more prompts and then Lex and more variants, and then Lex would choose one of these prompts when asking customers. So slots can also have sample utterances. So basically, if I would provide some sample addresses here for slots, I could do it and just click the button, add the utterance, like different ways that customers could say the provided location. For example, I'd like to stay in London. That's like, for example, a sample utterance that we could use here. And this is now the wait and continue feature that we mentioned before. So basically allowing customer to ask for more time. So basically saying, hold on to Lexbot, and then Lex would wait for customer to get the information back, such as credit card number. So again, we can configure the responses when user wants bot to wait, and then responses when the bot to continue to wait, and then finally the user when user wants to continue. So when user is ready, this is the response that would be played back to the user. Okay, very similar for the custom slot type. So we can see that this slot is required, and then basically this is the prompt, and we can see that slot type is room type values. Okay, so we also have the confirmation prompt for our intent. So if customer was happy to proceed, we would say, okay, I have you down for a number of nights in a particular location. Or if customer declined the intent, we can say, okay, I have canceled your reservation. Now the call hooks are currently not configured in this example, but basically this is where we would enable the call hooks to validate the user utterances. For example, we want to limit the number of cities that customer might pick, basically cities that are supported by our business, or some similar validation. And then we have the Lambda function for the fulfillment, and this is basically once the intent has collected all the slot values, this is where the Lambda function would be triggered to basically store that booking into a database, or for example invoke an API to store the booking. Okay, so this was our book hotel intent. So if we go back to intent list, we can also see different slot types. So basically we have car type and we have room type. So very similar. Let's see the Spanish language. So we're going to go to the intents, and again we have the same set of intents. Let's this time look at book car. So basically we again have the conversation flow, which is very useful for the authors. And then basically we have the sample addresses on how a customer might say that they want to book a car. And then again, the same, we have the slot and the slot types on what parameters Lex would need to get from the customer. For example, pickup city, pickup date, return date, and so forth. So as you can see, we can use different phrases for different languages, but still all the languages are contained within a single bot. Now let's check the let's go back to the bot versions, and then we can see that we have draft version, which is the default one, which is the editable one, and then we have the 4 other versions. Let's click on the version 2, for example, and if we click on the version 2, we would see exactly how that bot looked like in version 2. Or if we click on version 1, we would again see how that intent looked like in version 1. Here on the screen, you can see that version 1 only had 2 languages, so English and German, while if we go back to, for example, version 2, we can see that version 2 now has 3 languages. Okay, so if we want to create a version, basically we would click Create Version, provide a description for that version, and then include the languages that we want. Okay, so by default, all the languages are included. And if we click on the advanced settings, we can say that we want particular languages and basically from which version do we want that language. So maybe we were just working on one particular language that we want to include in a new version of the bot rather than all the languages together. Okay, now let's see the aliases. So this is how we control which versions would be in use. So instead of pointing our applications, in this particular case, Amazon Connect, to a specific version, we always create an alias and point Amazon Connect to an alias rather than a version. And then we point alias to a particular version. So as you can see, we always have this test bot alias, and this is the draft version. So this is the alias which we get by default. And then we create a new alias and we say that Connect Production or Connect Prod has the associated version as version 4. So if I click on Connect Prod, I can see that it's pointing to version 4, and that includes all the 3 languages. Okay, so I would be able to see the conversational logs and so forth. If I want to change Connect Prod alias to another version, I would click Associate with the version, and then I would change the version. Similar, if I was gonna go and create a new version, so I can click Create a new version, create it, and then basically come back to aliases and then assign that version. In this case, that might be a version 5 of our bot. And this is how we can easily control on what is in production and what are we using for our customer experience versus what authors and developers are working on, which is always in draft version. This one is mutable. Okay, once we created our Lex bot and once we published a version and assign an alias to that version, we have to enable Amazon Connect to integrate with that Lex bot. So basically, we would go to Amazon Connect console and then click on the contact flows. And here, from the list of bots and versions, we would assign a particular bot and alias to that Amazon Connect instance. In this case, we have assigned the testbook trip bot with the alias Connect Prod. So Amazon Connect, in this case, cannot use any other alias or like any other version that's not assigned to this alias. Okay, now moving on to the contact flows. So the main goal was to reuse both Amazon Connect contact flows and Amazon Lex bots. So now we have seen how we can reuse, how we can use a single Lex bot for multiple languages. Now let's see how we can use Amazon Connect contact flows to handle multiple languages. So I'm going to quickly switch to Amazon Connect console. And this is where we have our contact flows. So we have our intro flow, and then we have our main flow, and finally we have our customer queue flow. So the customer experience would be customer would interact with the intro flow, then it would interact with the main flow, and then while the customer is waiting in a queue, This is the weight treatment that we are providing to the customer. Now, the way to enable multiple languages in a single set of Amazon Connect contact flows, we are using a pattern that we published earlier, which is basically building multilingual voice experiences in Amazon Connect. This is a blog post that was published, and basically it uses AWS Lambda and Amazon DynamoDB to do that. So our contact flow in Amazon Connect would invoke a Lambda function. Lambda function would, based on the language and based on the channel, so we can support different channels, in this case voice and chat, it would retrieve all the messages for that flow from our DynamoDB table. I'm going to include the link to this blog post in our presentation. So if you have time, take a look at this approach in more details. So let me quickly go to Amazon DynamoDB. So in our DynamoDB table, we have message groups. So in this case, each message group represents a contact flow. So for example, we have intro, we have main, we have customer queue. And within the message group, we have different messages that we want to play to our customer. So we have message ID, which is the intro message. And then we have the message text, which is split across different languages. So for example, we have Spanish language and we have English language. And then it's split across chat and voice. So for example, in voice, we can use SSML tags. So we can say, thank you for calling Amazon Connect Contact Center. And we can include other SSML tags here to basically define how Amazon Polly would produce the text-to-speech. For chat, we want a different phrase. We want welcome to Amazon Connect Contact Center. We don't want thank you for calling, because customer is actually not calling when reaching through chat. Then we have the language selection prompt. So basically this one in Spanish, it says, for Spanish, please press hash. So very similar, we have the main flow and the main the messages for the main flow. So basically here we have the initial bot question, so which is how can I help you today, for voice, for chat in English, and then for voice and chat in Spanish. And then different phrases, for example, when bot reservation was not placed, when we want to disconnect the call, when the hotel reservation was placed, when the car reservation was placed, and then when customer asks for the agent support. Okay, so as you can see, we always have message ID, and for the message text, we have language, and then we have separate messages for voice and for chat. Very quickly, we have the same for message queue. So this is a message that we play while customer is waiting in our queue. Okay, so from the contact flow perspective, we start with our intro flow, and this might looks complex, but this is the basically the complete setup that would allow you that from this flow you can use multiple languages in any other flow. So what do we do at the very beginning is we are checking if the contact was chat or voice. If this was a chat contact, we don't have to ask our customer to select a language, because we would expect the customer has already selected a language on their website or on their mobile application. So basically, if this was a chat and customer selected Spanish language, then we're going to set the voice as the Spanish speaker, Miguel in this case. And if this was an English speaking customer, then we would set the voice to Joanna. However, if this was not a chat, if this was a voice, we would greet our customer and say welcome, and then we would play a prompt allowing customer to select a language. We would say, for Spanish language, please press hash. So the important to notice here is that when we set the voice, we also want to check this checkbox, which is set language attribute. And this is very important, as this language attribute would then be passed to our Lex bot as well, and the Lex bot would automatically select the appropriate language based on this block. Similar for English, so basically we also set the language. The very first step after we determine if this was a voice or a chat contact is to invoke our Lambda function, and this Lambda function retrieves all the messages back from the DynamoDB. So basically the message group is the intro, and all the messages that are in intro based on the language and based on the channel would then be retrieved from DynamoDB. From this step, moving on, basically we can play a prompt, our welcome prompt basically, and we say that this prompt is the message ID. So we don't have a single hard-coded message text or a prompt text in our contact flows. We only provide the message key, and it's the Lambda function who determined what the appropriate text was for that prompt. Could be chat, could be voice with the SSML tags, and so forth. Okay, so, and for example, this is where we set the language to Spanish to be able to ask our customer to make a language selection. Okay, so once we made our language selection, we set the language and then we transfer to the main flow. So this is all the setup basically that you need to enable your customer to, if they're using voice, to select their language, or if they're using chat, we are not asking them, we are just getting the attribute that was passed by a mobile application or by a website. Now moving on to the main flow, again, at the very beginning, we invoke our Lambda function, the very same one, and this time the message group is main. So we want messages for the main flow, and then basically that Lambda would determine if this was a chat contact or if this was a voice contact, what was the language selected previously, and then based on all of these parameters, it would only retrieve the messages for this contact flow. In the contact flow, it's a very simple contact flow, this one. So we have the get customer input to ask customer. So this is the bot init question. So we don't have the actual question in the contact flow. We only have this message key. And based on that message key, if we go back to DynamoDB, we would see that the question is, how can I help you today? Or if this was a Spanish, we would read a Spanish message. And then based on the customer interaction with the bot, as the outcome, we either have the hotel booking. So we are going to play a prompt that the hotel reservation was placed. Similar, the car reservation was placed, and then basically if customer was asking to speak with someone, to speak with an advisor, to speak with an agent, then basically we would play a message with the agent support, set the queue, and then transfer that to our queue. So this is basically how you can play the messages without worrying about the language and without worrying about the channel, because our Lambda function would do all of that and prepare these messages for the contact flow. As we transfer the customer into the customer queue flow, this is the wait loop. So again, at the very beginning, we invoke our Lambda function to retrieve the messages for the customer queue, and then basically we loop the prompts. So basically, if this was a voice contact, we would play some music, and if this was a chat contact, we would just play or display the message to asking customer to wait until an agent becomes available. Okay, now let's see this in action. So I'm going to place a test chat contact. So I'm going to use this test chat page. And in my configuration, I'm saying that basically the contact flow is going to be my intro flow, and that the language, let's start with English language, for example, so that the chat language is ENUS or the English. Apply this. And the new chat contact is started. We say welcome to Amazon Connect, and the bot says, how can I help you today? So from here, I can say, book a hotel, what city, let's say London, and then what day. So let's try tomorrow. How many nights will you be staying? Let's say 3 nights. And then what type of the room? Let's say queen. And the bot would basically say, okay, I have you done for 3 nights stay in London starting on the 8th of October 2021. Shall I book the reservation? So although I said tomorrow, the bot was using the natural language understanding, I was able to translate that into a particular date. So here I can say, yes, please book my reservation. And then the bot would say, thanks, I have placed your hotel reservation. Thank you for contacting us. Okay, so this is all in English. So now we want to reuse all the same bot, same contact flows, just for the Spanish language. Let's say we passed a Spanish language code from our website or from our mobile application. We apply, and then basically chat starts, and it says in Spanish, welcome to contact center. And this is basically in Spanish, how can I help you today? So let's say that we want to book a hotel, and then it's asking us about the city. Let's say this time we are going to Madrid. And when do we want to our booking to start? So basically this is going to be again tomorrow, and then the number of nights that we want 3 nights, and then the room type again. So we provide a room type, and then the bot is asking us to confirm. We say sí or yes in Spanish, and that's how we booked our hotel. So again, using the same Lex bot, using the same set of Amazon Connect contact flows, we are able to book our hotel in 2 different languages. Now, as promised, I'd like to share some resources with you. So first of all, we have Amazon Lex V2, how it works. There's a link, and then the list of supported languages. Please check this out. We have new languages coming up as well. About streaming capabilities, this is really a game changer in the contact center industry, where we allow customers to ask bot to wait until they get the information. We also have a link for the V1 to V2 Lex migration. If you have existing bots, please check that. And then I'm also sharing the link for the building multilingual voice experiences in Amazon Connect, the blog post that I was using during my demo. Please check how you can create a Lambda function and a DynamoDB table to store all your messages instead of hard coding the messages in your contact flows. So this is the Q&A part. Thanks a lot for staying until the end, and please feel free to ask any questions you might have.